Okay, the streams are booting up, so hopefully they'll start appearing online for people any moment now. And we'll get confirmation that we're online, and then we'll start this thing, get this show on the road. All right, let's see here. So it looks like we've got people joining on YouTube and Facebook. If somebody could send us a message on there to let us know that you're hearing me okay and that you're seeing me. Looks like we've got people joining. We got a big crowd today, actually. That's awesome. Looks like we'll get ready to start in about a minute or two here. Just waiting for things to boot up. For everybody just joining, we're going to be taking a live tour here in just a moment of the Center for Engineering Innovation, Center for Engineering Innovation and Design at Yale. And we'll get started with that in just a minute here. Before we go into that, though, I want to say a huge thank you to DigiKey, who is sponsoring this. DigiKey has chosen to sponsor something that allows us to highlight the community, what's happening out there in the world of makers, and the stuff that's actually happening on the ground in the maker community. And we love that. We thank you, DigiKey, so much for sponsoring this. If anybody needs any parts for your next projects, go to digikey.com, and they carry everything. Anything you would need, you'll find at DigiKey. Now, I haven't seen any comments pop up yet. If you do have questions or comments, type them in. I should see them if everything's working, and I'll be able to ask the folks at Yale your questions. Otherwise, I think we're just going to hop into it and check it out. Let's switch over here and say hi to the folks at Yale. So, hello. I see you standing there. Tell me, who are you and where are you at?
Hi, how's it going? I'm Antonio. I'm with the Center for Engineering, Innovation, and Design at Yale University. I'm joined here with Ashton Oaks, who's another one of the design fellows here at the center. Ashton, say hi.
Hi. Oh, you can't see it. That's okay.
We're pretty much good to just get started then?
Yeah, let's do it. Tell me a little bit about the space.
Great. So, I'll just come up to you. Go ahead. Well, come on in. So, the Yale Center for Innovation, Engineering, Innovation, and Design is Yale's space for interdisciplinary activity across Yale's campus, created with the mission of being a collaborative hub of activity open to everyone in Yale's campus, so where they can come and take an idea from Post-it note or whiteboard to reality, and hopefully use the resources at our space to make that happen. And we have a mixture of academic resources, both through mentorship, faculty, courses, full credit-bearing Yale University courses, and workshops that members can engage with so that they can achieve the goals that they want to achieve and do project-oriented and project-based learning. So if we come on in, we'll just kind of take you through the space. Here we are. So walking in on the first go, this is our lecture hall. This is where actually we'll have classes being taught and presented. You can see I actually caught us right at the end of our finals period, so we don't actually have that many students on campus and using the space, so we actually look a little more empty than we normally are. But it's fine for us because we'll have a nice quiet space where we can show off the projects and show you the space that we actually use. In the lecture hall, we'll find the lecture hall is where we host spaces and courses that professors from Yale can co-teach classes. Some examples of that fully credit-bearing classes that we have at Yale University that are taught here in the space include introductory engineering courses. Most notable example of which is called ENAS 118, which is Introduction to Engineering, Innovation, and Design, where first year and sophomore students can come, coming from high school, not having any engineering or making background, and be a part of the space and learn hands-on through project-based learning the basic principles of various types of engineering and make from mechanical engineering to electrical engineering, chemical, biomedical, and computer science, and then use the resources that we have in the space to make hands-on projects and work with clients around Yale's campus to make solutions to problems that they have. Some of these problems may include Yale athletics, and the university athletics department says, hey, we need a method to measure how strong our football players are. or we want something to measure how fast our lacrosse team can swing a goalie or swing a stick. We can build things for them via projects from our students that they can then use on the field and in practice. Do you have any questions so far, Caleb?
I mean, I'm a little bit curious, like what percentage of the projects are like coursework, and what percentage are personal projects, and what are like requests. I mean, this is the first one that we've done that's been integrated into a university. So to think about the other departments requesting stuff is actually pretty awesome. Like how often is that?
That really is sort of where we base a lot of our success and where we love to thrive, is that we are in an interdisciplinary center that's open to all of Yale. What that means is right now we have about 2,500 active members. Only about 60% of the members of our space, which come from the Yale community, are Yale undergrads in STEM field. The other 40% are faculty members, staff members, and other students coming from places like humanities, social sciences, or undeclared disciplines altogether. So a first-year student might come in and say, I might want to do art, history, or I might want to do engineering. Either way, they might be an active member of the space and engage with the projects and classes that we have here. Why don't we come on in, and I'll give you the tour. So this is our studio space, a large space dedicated to students working on projects, both hands-on and maybe homework that they might have, and using the resources that we have here. Fun, interesting tidbit, a little bit about the history of our space. 7 years ago, what you see here, this wonderful space that's currently integrated in a part of the Yale community, was not so much so. It used to be the engineering library at Yale. So instead of the fun studio work and the tools and the crafts in this area, over here, it used to be just stacks and stacks of library books. So they said, out with the books and in with the tools, and created this space so that students can come and work and collaborate and work on their ideas and make them into reality. So the general tour, and we'll definitely get to students, hey Nathan, the general tour, and we'll get to student projects as we move further down. But I like to walk around with this narrative of, you're a student at Yale, you walk into our space and you say, I have an idea for something I want to build, whether it's a knick-knack or a Christmas present or a full project for a mechanical engineering, electrical engineering class. You can come into our space and follow our prototyping to reality pipeline, and you do that to achieve your the goals that you want, starting here with our prototyping area. Everything you see in the blue bins is available 24/7, where we are a 24/7 facility, available 24/7 for students to use as much of and however they want. So anything from bungee cords, styrofoam, pipe cleaners, and pom-poms to post-it notes, tape, all sorts of Legos. A space wouldn't be complete without different types of Legos, glues and epoxies, and different types of paints, as well as a collection of different pieces of cardboard, foam core, and other things like styrofoam and aluminum foil that they can use as well. We typically have these items fully stocked so students can use as much of them as they need, and then ask the staff members here to replenish them as needed. And we do that, fully free of charge. Students can just come in and use as much as they would like. Run in over here. And then as they start to move on from those prototypes and develop more in-depth projects, they can come over here and start to find resources for the advanced projects, whether that be mechanical resources or parts, or electrical components to circuits. On the left side, we have those electrical components. So every set of resistor or circuit element that you might need, that they can then bring over to our electronics benches and use for integrated circuits, creating motorized projects, or integrating into their robotics experiments or other general interests. And then on the right side, the mechanical fastener equivalent that every student can come by and say, hey, I need a 832 quarter-inch screw, and we can totally give them that screw for them.
Man, I'm jealous of this.
We definitely encourage both in collaboration and using the space intelligently. And so we have at the bottom of these drawers things like project leftovers that, say, a student has worked on a project that they got an A on, they turned it in, they don't need it anymore, but they don't want to throw it away. They can put it in these leftovers bins, and then other students can come in and say, maybe there's a part, there's a hinge, there's a bracket in there, or a circuit or a motor that I can use from a future project of my own, and they can continue to recycle these parts and turn them into cool items and projects.
Very nice.
We need to move forward. We have things like the sewing station. So you've got your robot prototype, and you've made it out of silly string and Legos and super glue. You've picked out your resistors and mechanical fasteners, and now you actually need to make some fine detailed clothing or fabric attachments to this robot. So we have sewing station here, and because we are an academic facility, we do strive for teaching and encouraging our members and empowering them to learn by doing, learn by collaboration, and learn on their own. So we provide these things called the handy dandy CEID blue manuals, where we are able to encourage the students to read through, try to learn the different types of machinery on their own, and be able to achieve the projects that they want to achieve. We also, for the sewing machine, provide different sets of resources like fabric and fun things like yarn and string that you can use as well.
So I've got a quick question. You've got the blue manuals, and you've got classes that are in the space. Do you also have like process training? Like some makerspaces will have, like you know, teaching people how to make foam armor and stuff like that. Do you have additional training that's not, you know, credit based or anything?
Absolutely. So in addition to full credit-bearing courses, we actually offer weekly workshops. So every Wednesday night, open to every member of their space, they can sign up for a weekly workshop where we'll cover various things. But basically, it's an opportunity for them to spend 2 hours in our space learning a new skill or exploring a new area that might be of interest to them that they wouldn't otherwise be able to have exposure to. These workshops will often bring in local, maybe I wouldn't say experts, but people who have more experience in that field to teach other members about that. Some examples of that include a engine deconstruction workshop. So we'll have 10 one-cylinder engines, and members of the Yale race car team will come in and teach members about the intricacies of an engine and teach them how, you know, a piston works and how a one-cylinder combustion engine works. And then they actually get to come into the space and take those engines apart. I believe some of the photos you used in the promotion of this live virtual tour was of that engine deconstruction workshop. Okay. Some of our other workshops include things like analog electronics, woodworking, the math and science behind bubbles, and so we'll actually blow bubbles for about 2 hours and talk about the different mathematical equations that are achieved through bubbles. And then our most popular workshop ever is our chocolate tempering workshop, where we actually teach members. They can be students, they can be grad students, or they can just be members of the Yale community who come in to learn about different skills. And we actually teach them about the science behind tempering chocolate, what makes good chocolate versus bad chocolate, the actual chemical processes that chocolate goes through to become a tempered bar. And then we actually take them to our vacuum former and create our own molds. This is the CEID logo, but students can also happily walk away with a screwdriver, chocolate bar, a wrench, or their dorm room key in case they lose theirs.
Nice.
So for general access to the space, we say it is open to the entire Yale community, pending an orientation. So what we do is we offer weekly training services that I will host or Ashton will host, so that students can come in and get oriented and trained, learn about the different resources that we have in our space, and then get swipe key card access to the center 24/7, so they can come in at 3 a.m. or 3 p.m. to do any work or project working that they want to do. Want to keep going?
Yeah.
And then after students have been generally trained, they can then sign up for more advanced trainings, which include things like our 3D printers, our laser cutter, machine shops, wood shops, so that they can then get access to the more advanced machinery and equipment that we have. Moving further along past our sewing station, so now you have your prototype that you've created from the crafts area, but you actually want to create now a 3D model, and then hopefully move that over to either the laser cutter, the 3D printer, or some more advanced machinery. We have various design computers at these workstations that students can use to work on design simulation programs, things like MATLAB, SolidWorks, Rhino, and then the entire Adobe Creative Suite, so that they can create actual digital models of the prototypes and ideas that they have, whether that's for personal projects, for startups that they have, or for class. That's up to them. And that's another really interesting and important factor of this space, is that we really are open for students and members of the community to foster and create their own ideas, from really low-level sort of for class or for personal use projects to student projects and collaborations that end up becoming, $1 million funded projects and startups that go out to hopefully change the world, from in the medical device industry to athletic tech to finance and everything else.
Nice. We've got a couple of questions. Yeah, we've had some questions that have rolled in through YouTube. First off, your family is watching from Florida, and they say hello. Gator Fred's Fun and Party Center. And then we have some people asking, let's see here. Zmajum is asking if you have a ceramics design area as well, if we'll be able to see that.
So we don't have a ceramics designer area like that. Around Yale University, there are various different spaces and centers that focus on things like pottery and ceramics making, and there is a dedicated person at Yale to help students with making ceramics, making pottery, that they can then come in to add modifications to their to the ceramics and things that they've made in our space. We don't have a dedicated space or resources for that, unfortunately.
It's okay. You can't have everything under the sun.
Yeah, unfortunately, we do have a limited space, so we have to choose the resources that we can and can't have. But what we hope is that a lot of the space is dedicated, and the machinery is dedicated to facilitate what a lot of the students are interested in.
Nice.
As we move further along, I'm kind of taking you on a circular tour of our space. So as we move further this way, you've got your digital model of your prototype. You've got your prototype made out of Legos and hot glue, and now you actually need to use tools to create those products together. So this area is our tool bay. Everything that you would need to either rip things apart or put them together. Different wood saws, hacksaws, hammers, various fastening equipment on the other side, different sets of pliers, shears, wrenches, and other tools like that. You might think, why do you only have 7 screwdrivers? What happens if more than 7 people want to use the screwdrivers? Everything you see on the walls, we also have in these drawers. So we do have other screwdrivers, not just the 7 on the wall. The way we staff the space, we have 4.5 full-time staff members. What that means is that 4.5 people who are here dedicated full-time to helping students and courses achieve their goals through the space. Excuse me. I say 4.5 because the half comes from our director. His name is Dean Vincent Wozinski. He spends half of his time here as the director of the space, and then he spends the other half of his time as the deputy dean of the School of Engineering and Applied Sciences for Yale University. On the other end, we've got Dr. Joe Zinter, who is part of the design faculty here and the assistant director of the space, who also teaches some of the more advanced courses that we offer to students, things like biomedical device and innovation course, as well as a course called Making It, which is a product design and entrepreneurship-based class offered at Yale. On the other end, we also have Dr. Larry Weiland, who is a research scientist and physicist and a design mentor of our space, who co-teaches classes like the Introduction to Engineering, Innovation, and Design class, but also more specialized classes. For example, one class that he teaches in this space is called Musical Acoustics and Instrument Design, where students learn about the principles of musical instruments, what makes a sound produced from a string instrument like a violin different from a sound produced on a percussion instrument like a xylophone, or a wind instrument like a saxophone. And then students actually get to use the space, use the 3D printer, use the wood shop to create these, to create models of these actual instruments and learn about the physics behind them. The last 6 weeks of the course, students actually get to create their own unique, never before played musical instruments. And we have some of those on display if you'd like to see them.
Oh, absolutely. When we get there, for sure.
So, to show off the first one here. This one was created a couple of years ago from a student in the class. You can kind of probably tell what it looks like.
Yeah, that looks
It's
like
called,
a violin.
The Ponte violin. Exactly. It's a completely electromechanical violin that was created by a student who double majored in both electrical engineering and computer science, who found inspiration in the theremin. They wanted to create an electronic violin that, instead of strings, used fretboard-linked touchpads that connected to a potentiometer and then turn the DC motor that could create a voltage and determine what note needed to be played so that they can then connect this to a computer and actually produce some interesting sounds through that. So then on the other end, we also have more completely digital instruments. So as a part of this class, so fun fact, I was a student at Yale University, graduated and have now been brought on full-time to work here in the space as a design fellow along with Ashlyn, who also graduated in architecture. But when I was a student, I actually took this course, the musical instrument device and design class. And with the help of Larry Weiland and the professor at the School of Music, who co-teaches the class, Conrad Kasmerick, I was able to create my own musical instrument, which I call the Dyno, which is right here. So I'm a saxophone player at heart. I've played saxophone for about 10 years, and I wanted to create an instrument that, despite all of my sax professors telling me that no matter how much I moved around when I played, it wouldn't make me sound any better, I wanted to make an instrument that did. So this device connects wirelessly to the computer, where I can play and connect to different sounds in a live synthesizer. So what I did is you can play different notes on the buttons and then use the gyroscope built into the machine to achieve different sounds. Can you hear the sounds coming out of it?
Yeah, that is wild.
So that's a device we have here. You can come on to take a look. We actually have it connected here. We've got several PCs that students can check out and use the design programs there. That's Ableton Live. So then I connect it to this, and then you can start to play different noises on there.
That is so cool. So when somebody designs something there in the space, such as that instrument, does that ever get published to the public anywhere where other people could maybe reproduce it or learn from it?
So you're asking if it becomes sort of open source?
Well, it doesn't even necessarily have to be open source. Do you share like your build process, or you know what I mean? Is there anything beyond just the classroom end product?
Definitely. So typically what we say is what the students do with the projects that they create, whether they want to publish the exact things that they use to create each prototype or each model or each circuit. That's definitely up to them. As far as for us, we don't typically publish everything that we create, but rather use a lot of open source material, like resources from Arduino, resources from what's already open source, to sort of encourage students to build on those tutorials, open source devices and machinery, and create their own unique innovations or inventions from that. And then usually from there, they either we say they either create their own startup, and in that case, it's their own IP, or they move on, and then we get to keep these projects and show them off to anyone who wants to come into the space and take a tour.
Very nice.
On the other, so this is finally gets a demo project from the Introduction to Engineering, Innovation, and Design course. So this is a course dedicated to first years and sophomores who are just getting into making and learning with their hands and building circuits and using mechanical equipment. And we had a client with the Yale athletics team. So the Yale lacrosse team came to us and said, hey, we need a device so that we can quantitatively say how fast our lacrosse goalies' hands are. We want to be able to say, that's a recruit worth looking for, or that's not for life. Or I should say, we want to win championships, which Yale did a couple of years ago, which is great. We like to say that we helped them with that. So this is the light board, which I think Ashlyn is going to demo out for us too. All right, Ashlyn's got mad skills. So the idea is that they've got concentric circles that will map out our participants. All right, let's see your reflexes. So she's supposed to hit, in this case, all the red buttons. And this would have been a device made entirely in a couple of weeks by first-year students in our space that we then give to the client, in this case, the Yale lacrosse team, to use in their gym. All right, and your score was
97.5%.
97.5% after one.
Woo!
All right. And in reality, this is a miniature version of what was actually delivered to the team. The real light board was actually pretty large, and we were able to do that for them. So another course that we actually offer in our space periodically is one called Medical Device Design and Innovation. That's usually co-taught or at least guest lectured by professors and actual doctors and surgeons in the Yale School of Medicine and Surgery. Some examples of projects that we have there can be seen right here. And a lot of times, the students who produce devices and machinery in that class can actually go on to pursue these devices as their own startups or in their own companies or as part of their own research. So this was a machine. Ashton can definitely go in and look into a little further. Called On-Track Rehab. It's meant to help doctors better diagnose and rehabilitate patients with concussions. So they worked in collaboration with a doctor and a Yale athletic medicine representative. They built a 3-component system that features virtual reality headset with eye tracking, motion detection, and this is a physical balance board with adjustable stability using the gears that are right on the inside. And then, of course, an Arduino right there that can collect data about the stability of the patient based on their center of gravity, and then synthesize that data so that a doctor can analyze the recovery of each patient based on time after receiving concussion.
Wow, that's
pretty cool stuff. They actually just, thank you. They just won a Catalyzer Prize, and they're doing really great things, looking to further this project and hopefully move it into patients so they can use it pretty soon. Other examples of projects that came from that class. This is a steronomy guide. So the idea behind the project is that working again in collaboration with actual doctors at the School of Medicine, the students are able to, they wanted to minimize steronomy associated complications, which is a type of spinal surgery, and created a guide for surgeons to basically guide the blade or the knife with as they insert using a series of links. They can use this alignment system and use hooks to create sort of this pair of jaws that move in and out of the spaces in the spine. Then they use a sort of implant system to create a series of fixation and closure plates that securely mount to the sternum and rigidly connect the two sternal halves.
Very cool. Wow.
Awesome. And then we can show you maybe one more project that came out of that course. This is one called Cushy Baby. So you can see this necklace right here. This is created in a class called Appropriate Technology. This Cushy Baby system is actually being put into place in India. It's a necklace with a computer chip inside that stores up to 2 years of vaccination records for young children. The idea is that it uses NFC technology so that places that are in greater poverty and don't have access to maybe more advanced medical technology and medical record keeping systems are able to keep their data in a cloud-based storage system so that a child won't go without having the proper medical records stored in their spaces so they can actually receive the proper vaccinations from year to year, or from clinic to clinic. That can all be accessed together. That's being put into place in India right now from a Yale alum who was a graduate of this class and a member of the space as they created that in here.
Very nice.
It's very cool stuff.
I have to interrupt real quick and just say, this is the best camera work we've had on a tour so far. Great job.
Thank you. That's all due to Ashley. She's got an eye for good camera work.
I have an eye and an iPhone.
There you go.
So this are moving over to our electronic station. So say you've got your prototype completely built. You've got your model made out of silly string and Legos and hot glue, and then you've got your actual fasteners. You can bring it over here to our station to run soldering, analyze circuits, and cut, strip, and shear different wires. So each bench comes with a soldering station, oscilloscope, power supplies, as well as similarly to the blue bins, different sets of consumable items that students can use. So if a student comes in and says, hey, I need a 9-volt battery for a project, they can grab a 9-volt battery. Hey, I need a micro USB cable, they can grab those. They can also grab different tools, screwdrivers, for analyzing and taking apart circuits. Of course, multimeters at every station, and then other tools that we can use as well. And these are typically pretty well frequented. Again, right now we're pretty empty because every student here is pretty much either in a final or done with finals. So you caught us at an empty time That's pretty good. So you'll typically, if you come here throughout the day, you'll find students working on it pretty avidly. I'd also like to take this opportunity to look outside our window. So we do have a pretty open space that you can just see from the outside sidewalk. We just got hit by a pretty strong cold front, and so the ground outside is completely icy. But students still make their way outside to join our space and be a part of what we're doing and making and creating here. We've nicely transitioned over to the 3D printing area, so you can see a lot of our knickknacks. You can see the, there we go.
Oh, nice.
So we've got 5 3D printers in the Center for Engineering and Innovation and Design, 3 MakerBot Replicator Pluses that are available to students that have been trained in 3D printing by us and certified by our staff, that they are able to use 24/7. So they can basically come in, launch a print, and then come back a couple hours later and pick that print up either from the printer directly or from our finished 3D print storage bin that we have over here. And then in addition to that, we have 2 higher-end printers that we reserve for use via the staff. But we allow people to request specialized use for. So say someone has a project that they want to work on that requires high resolution, requires polyjet printing rather than FDM printing, or requires dissolvable support material because you're using complex geometries. They can send those projects to us, and then we can print those on the printer so that we can get that to them and they can go on and achieve their prototyping process and continue to prototype their projects. One fun example that we have of that, this is an upright to a car, again, made by Bulldogs Racing, the race car team at Yale University. And they were able to use our 3D printers to create pretty much 2-scale prototypes that they would then put into their working models and prototypes of the race car before they actually determined if it was an appropriate fit. So that rather than going into the machine shop and making something out of aluminum just to have it fail, they were able to create a prototype, and once they've determined that everything worked the way they wanted to, actually go in the same space or in the same span of time and create sort of an identical aluminum version versus the plastic 3D printed. Any questions on 3D printers in our area?
Not really. We've had a lot of people saying hi from all over the world.
I figure most people watching are probably pretty familiar with that, but it's always fun it's usually when any tours coming by the university show off this space, they stop right there to show off the 3D prints that we have available.
Yeah.
So we also have 2 more design computers, as well as more of the blue manuals for doing image processing, like creating vector images, or using other machinery like our vinyl cutter. So if someone, say a college student wants to come in and make a sticker for their dorm room, or they're creating a startup and they want to make stickers to give out to their potential clients, they can come into it and use our vinyl cutter to make that happen. We actually have the CEID logo right there for making vinyls. And then we also have a virtual reality setup, so students can come in and use the Oculus Rift to start working on VR projects and maybe do some app development in Unity, things like that. As we move further along, we also have our machine shop. So in our machine shop, we've got fully stocked 3 CNC mills, 2 lathes, and then on the left side, bandsaw, belt sander, drill press, and other regular machine shop tools that are available to students for use by the students after they've completed additional certification training by our staff. Moving on to the right side is our laser cutter that we allow students to use during staff hours during the weekdays. So they can come in, take a piece of scrap, put it into the laser cutter, and then receive mentorship and training by our staff members for their projects so they can achieve cuts that work, that are consistent, and then that makes sense for the projects and classes that they're trying to do that stuff for. Kind of scattered right now, but we recently, just finished up our semester, and so we've got some examples of student projects that have been created in the last iteration of Dr. Joe Zinter's Making It, which is a product design and entrepreneurship course. In this course, students get to learn about the many different facets of product design and development, before they actually begin designing their own products, they were introduced to different aspects of the design process through the process of building their own Bluetooth speakers. So each student in the class builds their own speaker. This is part of the built speaker kit. The first half of the semester is dedicated to building the circuit, milling the wood, and using equipment like the laser cutter and the water jet to create these Bluetooth speakers. So each student can walk away with this really cool, really nice looking device that they created really all by themselves. This year, a lot of some of the examples of the student projects include a football helmet with a heads-up display that is able to display different, actual plays by the coach and relay them to images displayed in front of the player's eyesight. On this end, a directional speaker. So this speaker, if you point it at you right now, it'll sound pretty loud. If you move it away, you won't hear anything at all. It's got a camera built in that uses motion tracking and facial recognition to basically follow you along as you move. So if you move around the room, your music moves around the room with you. And then finally, the last student project. These are projects made composed of student teams of 3 to 5, made completely mostly of juniors and seniors in college. Is a smart composting device that is essentially aimed to make composting fun and accessible for use in the kitchen and the home. And they created this essentially using only resources in the space, using the laser cutter, using LED light strips that actually turn on and give you quantitative data about how your composting is going.
That's pretty cool.
So any questions, Caleb, or how are things going?
It's a very wide range of projects there. It's really interesting. It seems like in an academic location, you get a lot more diversity in the concepts people are wanting to explore.
Yeah, absolutely. And that's really what we sort of strive and want to do. The mission of the space was to be an interdisciplinary center and hub for collaborative activity on Yale's campus. And we try to achieve that through hosting a different variety of workshops that are open to the public and our members, that include things like engineering with engines, or analog circuit building, or things like chocolate making and chemistry. And those are open from people from people of all backgrounds, either engineering who just want to revamp their skills, or someone again in the history department who wants to come in and make a puppet on the sewing machine, or actually 3D print some objects. And basically every single Christmas ornament and gift that I've given to my mother every Christmas has been made on the 3D printers. And every year she says, "Well, that's amazing, you're such a genius." And I go, "Yeah, I know." But really it was just a lot of the simple skills that I learned in this space. But I know she's listening, so I won't tell her that. But it's a really great space. And then on the other end, we sort of encourage interdisciplinary sort of pedagogy through our courses, right? So we don't just have general engineering courses. We have product design and entrepreneurship through making products, right? We have musical acoustics and instrument design that we actually co-teach with a composer in the School of Music and a research scientist in physics, which is Dr. Larry Weiland, who's a design mentor in space. And then we have things like medical device design, who again we co-teach with a surgeon or a doctor from the School of Medicine and a design mentor in the space.
Very nice. So if somebody was watching this and wanted to learn more about the space, where could they go to learn more about the space? Is there a website that has information on it and how they could access it if they're local?
Yeah, absolutely. So you can actually go to ceid.yale.edu and you are able to check out our space, see what we're all about. If you are checking this out and you're a young student in high school, I would encourage you to check it out, apply to Yale, and hopefully you'll get to be a part of our space one day as well.
Very nice.
Yeah. We also have a mezzanine floor where we'll be able to check out. So right now we've got a couple of students working on their looks like Christmas gifts. Yeah. We got Christmas gifts happening right now. Students just coming in to work.
So we've had a question come in from John Kulpoff, who runs a space in New Jersey, and he's asking what your greatest challenge is. Is it funding, staffing, training, student creativity, or something else?
So the creativity really comes from the students, and we see, every day we're pretty much surprised with how creative the students can be. So I don't think we're running low on creativity. As far as funding and staffing is concerned, we're very fortunate that we are under the umbrella of a university, and so we do receive funding through various avenues there to encourage students to, achieve the projects that they want to achieve, to fund student projects to grow further, maybe grow to be staffed and contributed by more students or other staff members. So very fortunate that we really don't have a lot of the difficulties that might face other centers or spaces. On that note, up here in the space, we've got two fun offices. So in here, we've got the office of our director, Dean Vincent Polzinski, who's in here working hard right now. And then over here is our wet lab. I think the camera, Ashton, can say a few words about the wet lab.
So in addition to all the equipment that we have downstairs, so wood shop tools, machine shop tools, 3D printers, we also have things for the more clean and sterile types of work. So upstairs we have a lower level lab for sort of more simple microscopy, biology and chemistry work. This is also where we'll bring our 3D prints from the F370 or the object printer for cleaning. So we have a bath of basic solution where the F370 prints will soak, and then a pressure washer for the object to remove that support residue. Bubbles for the Bubbles workshop. Dremel 3D printers, as well as some microscopes that we can use as well. So a phrase that we like to say is downstairs the dry, dusty, and dirty. Up here's the clean, wet, and the squishy.
Nice.
Here's a view of the classroom.
And then finally, the space, other than being used for working on student projects and achieving your dreams, a lot of students will just come in here and work in our one of the 6 meeting rooms that we have available. So students come in and use the TVs, use the tables, or use as much of the whiteboard wall space as they want for working on their calculus homework, working on their language studies homework, or whatever else they might need to do. But a lot of times we'll see things like students collaborating on ideas, pitching ideas for startups, or just doing late night homework and eating snacks up in our space. And Ashley's going to give you a nice aerial view of the center.
This is just fantastic. What a nice space.
Great thinking. I'd love to answer any other questions that you have, Caleb, or any other questions from the comments.
That's really it as far as questions go. I mean, I'm curious what it's like whenever things are busy, or I mean, is there a big? Do you find that there's like a common theme that you see coming out of there, and like you have lots of startups, I'm guessing, since you're kind of in an academic environment, it seems to breed that kind of thing. Do you feel like you're kind of a launching pad for that, or do you feel like there's more tinkerers, or how do you feel the split is?
In a lot of ways, there's tons of both. I would definitely fall into the tinkerer category. When I was a student here, even now, I'll come in and just say, I want to practice learning how to run a DC motor. And we have things like Arduino kits from SparkFun that students can actually check out and just play around, run an LED, run a motor. And we have tons of people doing that every single day who come in and say, can we check out an Arduino kit and do that? That's all, of course, free of charge for the students. On the other end, we do have students who are actively in here working on projects that they want to jumpstart to the next level. And we work in collaboration with other spaces and resources on campus, say, for example, the Sci Center for Innovative Thinking, which is a space that is created to encourage and fund and help be a springboard and a launching pad for student ventures, student entrepreneurs, and student startups. That a lot of times, if it's a product or a physical device or machine, students can take from the prototyping phase in our space and then go over to other resources and other centers that they can then springboard into becoming a startup or becoming a small company. And otherwise, people just use the space, again, for creating knickknacks, creating projects, or trying just to learn a new skill, which is really, as long as the space is being used positively and contributing to the student experience at Yale, that's really what we strive to aim for.
Very nice. With most spaces, I ask how many members they have, but I guess with you guys, it's more of a fluid number because everybody's technically a member that goes to the school, right?
Technically, yes and no. So everyone, basically everyone who is affiliated with Yale is able to become a member. But really, only the people who have gone through our training process and our certification sort of process, which is really a painless 1 hour long orientation of me talking to you and saying, or me or Ashton talking to you and saying, these are the safety rules, these are the resources that you have, this is what to do in certain situations. Once they've completed that, then they are considered one of our members of our space. They receive our weekly newsletter. They get invites to our workshops, and that number really, on average, for all the members of the Yale community, we've got about 2,500 active members of the space.
Oh wow!
At any given time, we will have 2,500 members in the space. Although, if you were in here in the last 3 weeks, as people were in the last couple of midterms, people were turning in final projects. For a good period of 10 hours a day, the space is completely packed with people working on projects, whether that's electrical, mechanical, musical, whatever that might be. People really get a good use out of the space.
Very nice, very nice. Well, that's all the questions I have. Unless there's anything you really want to show us before we wrap it up, I'm going to wrap things up.
No, I think we showed you everything we got. Thanks so much for letting us do this.
Well, thank you very much for giving us a tour. That space is incredible. It's fantastic. If you wouldn't mind, stay on the line. Thank you. Is it Ashlyn? Thank you, Ashlyn, for the camera work. That was perfect. You're the first person who's nailed getting up close to things and showing us what the person's talking about and actually keeping it in focus. Hold on the line here while I wrap things up on the stream. And once again, thank you very much. Everybody check out their website. That is ceid.yale.edu. Yeah, okay, that's it. All right. So I'm going to wrap things up. Stay on the line with me there. All right, everybody. Thank you for joining us so much. Again, before we wrap things up, I want to say thank you to DigiKey for sponsoring this. They have been absolutely incredible. We value so much that they're sponsoring a community representation and not just an ad. So thank you again, DigiKey. Next time you're working on a project, if you just need to fill out a parts bin like what they had at Yale, go to DigiKey, order your parts. That's digikey.com. They have everything you need. Again, thank you very much, and we'll see you on the next Makerspace Live